Hello there. Look, Miss Coffee Bean is asleep. So, oh, isn't that sweet? Well, while she sleeps, I wanted to show you some of my own work. Miss Coffee Bean always pressures me to cover the notorious papers because those are the safest bet that will interest you and get heard, the clicks and the views. Okay, so quickly, while she sleeps, I would like to tell you about my own research and how that is going. In a nutshell, you know about the cool idea to replace the self-attention with the Fourier transform. Yeah, it's not like that. But you know what? It is honest work and interesting nonetheless. But first, I had to find myself some collaborators, or they found me actually. You know what? We found each other. So this is what we were up to, me and my collaborators. There was no Miss Coffee Bean involved, so better not wake her up, okay? Our work is entitled, in short, Seeing Past Words, because we are investigating whether vision and language models really integrate both the visual and the textual modalities, as opposed to faking that they are multimodal. I mean, there are reasons to believe that models meant for integrating image and text are actually focusing on language only, exploiting biases in the textual input. It was highlighted by previous work. This question of whether models are mostly exploiting unimodal signals has become more and more interesting since the dawn of transformer-based vision and language models, which follow the pre-train and fine-tune paradigms such as AlexMert, Wilbert, and many others. I've talked with Miss Coffee Bean quite some times about them on this channel. Quick reminder, their pre-training includes multimodal masked language modeling and image sentence alignment, where the goal is to predict whether an image and a caption match or mismatch. This pre-training on large amounts of paired image text data enables cross-modal vision and language representations that seem universal, usable for any task. Then taking such a pre-trained model and fine-tuning it on downstream tasks like these ones here is a good recipe for achieving at least close to state-of-the-art performance. So, given the success of these vision and language models, it is important to ask, how cross-modal are they really? We choose to answer this research question by developing a counting probe. Why counting? Because counting nicely combines visual and textual reasoning. Counting requires the detection of object instances in the image, mapping them to categories, and also properly aligning the instances to the reference in the textual input. This makes counting a very cross-modal task, thus should be solvable only by multimodal models. We formulate a counting task in a so-called FOIL setup by having images with either correct counting-related captions or foiled captions, which are slight but incorrect modifications of the original caption. We generate these examples automatically based on the VQA dataset called Visual 7W. We work with an interrogative format, but also with a declarative one. The model's task is to judge whether an unambiguous question or statement about the number of entities visible in a natural image is correct or a foil. We conduct experiments with Wilbert 12-in-1, and AlexMert in zero-shot and fine-tuned settings. All three models were pre-trained with the image sentence alignment task. Check this slide and the paper for more details. This image sentence alignment is important to us, giving us the opportunity to look at the alignment score assigned by the model, which reflects the predicted probability that text and image match. We use the image sentence alignment head during zero-shot testing to tell which ones are correct or incorrect counting examples and compute an accuracy score on this binary classification task. Results in zero-shot show that the models cannot solve the counting task. Prominently, Wilbert has a preference to predict the correct class to the detriment of the foil class. But we compute also a more permissive score, the pairwise accuracy ranking, where for a successful model response it is enough if the correct caption ranks higher in image-sentence alignment than the foiled one. Here we see that Wilbert 12-in-1 has a better response. The results on the declarative format are only marginally better. So the poor performance in the zero-shot setting isn't due to the fact that models trained on image-sentence alignment could have trouble with the question-answer format. In fine-tuning, the picture seems to change to the better, with performances increasing to even 81%. But does this mean that these models really count? No, or so our next experiment on the interpolated split says, where we fine-tune on even numbers and test on odd numbers. If the models are actually counting, then this should generalize sufficiently for them to solve the task in the interpolated case. But when we do this, Miss Coffee Bean, the model's accuracy drops to random chance. And we have even more experiments to underline the results we got so far with the image-sentence alignment head. So we have experiments with masked language modeling, where we let the model replace the numeral. The overall accuracy looks quite good at 55%, but it is just an artifact of the model predicting the most frequent numerals in training, like 0, 1, and 2, but being unable to go beyond 2. The same picture is painted by letting the model answer the question in VQA. For all the details and even more experiments for this, make sure to check out the paper linked in the description below. Therefore, Miss Coffee Bean. By means of our counting probe, we have found that vision and language models are still prone to biases and seem to learn broken heuristics that clearly do not generalize well. For further investigation, we encourage the use of our counting probe for diagnosing the absence of proper cross-modal alignment. Check out the link to the data on GitHub in the description below. Let us know what you think in the comments. Miss Coffee Bean, how long have you been awake now? Oh no, so you heard the whole thing. Are you mad on me now? It's research on multimodality, it's your favorite, right? You're mad, right?